Okay, we're going to go ahead and take a look at the first question from constructed response for Unit 6. This is a similar type of problem, just a different scenario. So in this example, it says the graph shows an exponential situation of a tiger wildlife refuge. The available territory is in hundreds of acres, and the graph shows the acres remaining after a specified time period. So over here we can see the graph. They've got some different parts labeled for us, but if we look at our axes, this is important to kind of figure out what we're talking about. Our Y is the available territory that's in hundreds of acres, and then the time is in years on my x-axis. So part A says, what is the y-intercept and what does it represent in the situation? So if I just start by looking at that first question. So if I look at my graph, a lot of you are really good at finding that y-intercept. Remember, your y-intercept is where x is equal to 0. Okay, so x is equal to 0 right here at 0, 500. So my y-intercept, if I write this out in words, so y-intercept is at 500, and that's going to be in hundreds of acres. So is that 500 hundreds of acres? Okay, so this means when I start, so if I look at time, time would be 0. So when time is 0, so when we're beginning the wildlife refuge, the tigers have 500 hundreds of acres. Okay, so when wildlife refuge begins, they have 500 hundreds of acres. Okay. So remember that that y-intercept is where you begin. So you can talk about whatever if you are talking in time. So when you start something, this is your initial value. Okay, so that's the y-intercept. Now here it asks, what is the x-intercept and what does it represent in this situation? So if we look at the graph, if I look here at my exponential, we've got exponential decay here. Notice how this right here seems to be, it's going to continue on and it's going to be hugging that x-axis. Okay, so there is no, remember we have that asymptote that blocks the function from crossing the bottom of that exponential function. So my x-intercept, there is none. So there is no x-intercept. Okay, and what this represents, notice here, this is available territory. If I went and I crossed the x-axis, well now my y values turn negative, but I can't have negative available territory. Like there's no such thing as negative acres. You can't have like land and then have negative land. That doesn't work that way. Okay, so there is no x-intercept because it doesn't make sense to have negative acres of land. Okay, so that's one way that I could describe that. Okay, so a lot of you are pretty good at this y-intercept and x-intercept, but just use whatever graph you have as your context. Make sure you pay attention to what your labels are on your graph, and that will help you describe the situation. So in part B, it says to describe the following end behavior of the function. Remember the end behavior, we're asking what is happening at the graphs at the end of the function. So it says as x increases without bound, so as my time increases, it's getting bigger and bigger, what's happening to the function of x? Okay, so this is my function. Remember that, I'm gonna label this up here. When on your axis, when you have like y, that's the same as me talking about the function value, okay? So as x increases, what's happening to my y or to my function value? Well, look, it's getting smaller and smaller. My y's, as my x's increase, my y's are getting smaller. I'm getting less and less available territory. So I could say that the function f of x is decreasing but will not reach 0 because of that asymptote. Remember, that asymptote's like that brick wall, and that function, my exponential function, will never cross that line. Okay, so in context of the situation, what does that mean for us? So if I write this out kind of as a sentence, so as x increases, instead of x actually, I'm going to put as time. So as time increases, because that's what x represents, so I'm talking about what it means in context of the situation, the available territory will be decreasing, but will never reach 0. Okay? Using the graph. So that's what the end behavior is in this function. So in part C, what is the average rate of change for the function between x equals 1 and x equals 10? So if you'll remember, our average rate of change, that's just our, kind of like using our slope, right? So if I go and remind ourselves of that slope formula, so y2 minus y1, and I'm going to put all that in, oops, divided by x2 minus x1. Okay, so that's really what we're doing here. So if we look at our values, so when x is 1, notice what y is. It's 145. And then when x is 10, so I'm looking here at the value of 10, it's not labeled, but we can see it's going through right at 300. So 10 would be at 300. So if I label that, so we can see that a little bit more clearly, 10, 300, that's the other point that we're going to use. Okay, so I'm going to let my y's be 300 minus 475, and then my x's 10 minus 1. So now I have my fraction, and I can go ahead and solve. So 300 minus 475, that's going to end up leaving us negative 175, and then divided by 9 for our x's. All right, so when I go ahead to figure that out, if I plug this in my calculator, negative 175 divided by 9, and that's going to give us negative 19.4. All right, so that would be my average rate of change between those two values, and I've shown all my work. So that's all you'd have to do for that situation. So they're saying that between 1 and 10, this is essentially kind of like my slope. It's describing the average rate of change between those two values, which would be different if I tested between like the points 10 and 45. Because remember, your exponential function, it's not changing at a constant rate. It's depending on which points you choose, it varies, which is why we find the average. All right, so then lastly, in part D, we have they give us the function. So the function f of x equals 500 times 0.95012 to the x. It's graphed above, well, to the right. The function g of x represents the total available territory after the wildlife refuge was granted an additional 200 acres that was promised to be protected. So somebody's giving them 200 acres that's not going to be touched. Okay, they're always going to get to keep that 200. So after the wildlife refuge was promised those 200 additional acres, what would the equation of g of x look like? And how would the graph of g of x compare to the graph of f of x? So we can look here, and I'm going to just copy my original function. Okay, so here's my function. And basically all we're doing is they're giving us an additional 200 acres. So if I have an additional of something, I add 200 to my function. And we know if we're adding something to the end of a function, that's a vertical shift, so a shift up or down. And since I'm adding that, I will be shifting this entire function up 200. So let me put it in context here. So this is my original function, okay, that they gave me. It's just kind of stretched a little bit different the way that we're viewing it. It's not zoomed in quite as much, okay? But then when I go ahead and I add that 200 at the end, I want you to see what this looks like. See how that equation was just picked up and it was moved. So here's my original function here in purple, and then my new one was just shifted up 200 units. So now my asymptote is going to be at that 200 mark, which means that my available acres is never going to go below that 200. Okay, so if I go back to describe that, okay, so I wrote the equation. What would the equation look like? Okay, so the new, oh, and this should say g of x because I am writing my new equation. So the new function, g of x, will be shifted up vertically 200 units. Okay, so then it asks how it would compare to the graph of f of x. So this means that the wildlife refuge would always have those 200 acres available to them because the asymptote is at y equals 200. And I spelled that wrong. There we go. Okay, so I wrote the new function for g of x. I described how it would look different. Okay, and then I compared it using words. So I talk about how since it's been shifted up, if we look at that graph again one more time just to kind of help explain that, see how when it's been shifted up, that new asymptote is going to be at 200, which means I'll never go on my y-axis, I'll never go under that 200 mark. So that wildlife refuge will always have that 200 acres available to them. All right, so I hope this helps with your number 1 constructed response. And if you need help, go ahead and watch the second video for number 2.